This conference will now be recorded.
So now we'll start this and recording. So I will go through a number of things here today. I'm going to start with the user interface tool, and then I will move on to show you some Jupyter Notebooks. If on your side you could mute your microphones when you're not talking, that'll keep the background noise down. If you need to contact me at all in the middle of the training, just stop me at any point, and I will do that. So I see a few people are still online. So if you can mute on your side, that would really help the audio.
Okay.
Yep, I see one going. Very good, very good. That helps. The audio will be cleaner now. So here we are today. Welcome. I look forward to this training opportunity to tell you a little bit more about what we're doing with the Open Data Cube and how it can help Tanzania. There's a number of new notebooks and features that I think will be quite valuable for your use, and I'm excited to show you those today. I sent you the document that you see on the screen. Sent it out. I expect most of you have that and can go back and refer to that. Again, I'm recording this session so that we have the opportunity, when it's done, I will post that onto YouTube. You can go back and look at this at any time to get an idea of how it all works. So the focus here today is to use the data cube for investigation of two things. I want to look at deforestation, agriculture phenology, and phenology being the agriculture seasonal variations. And so I'm going to show you some interesting things that we've done with phenology that I think will be helpful for agriculture studies. So the first thing we're going to start with is the user interface tool. The website that you see here is the website that is your Tanzania user interface, and that's dedicated entirely to you. I would suggest you use that one when you go through and do anything after this training. I'm going to be using a slightly different one. It's all the same in a sense that the one I'm using is the Strathmore instance at the higher level that has all the country cubes on it. And when you run the Tanzania cube, you can run through this one. So the first thing I'm going to do is just refresh your memory and show you how to do a cloud-free mosaic, how to download that mosaic, and to pull it out. So this is an example here you see in the document that I did one over Dodoma and Lake Salunga, and your city, I think, is right on the right-hand side here. I'm going to show you quickly how to do that. So if you look at the user interface, it'll look like this when you first go. You click on tools. You can either do things with water, land, or general, and general is the mosaics, and that's what we'll be doing here. So I go to custom mosaics and I pick the Tanzania cube. I then zoom in. I'm going to zoom in on, we're going to do something here near Dodoma. And let's say I wanted to make a mosaic of this area and I just want to go over the city and I want to see a Landsat 8 true color mosaic for something that's recent. So let's say I'm going to put 2017. So I'm choosing the dates in the bottom left. I've chosen January 2017. You'll see that it increments automatically for a complete year. So make sure your dates are correct. I've selected a bounding box by clicking in the left-hand side and dragging it down. So now I have my analysis box. I have my start and end date. It shows you the latitude, longitude bounds of your box. And as you see, as I'm moving the cursor around, you see in this top right corner, it shows you precisely the latitude, longitude. So if you want to find a particular spot, I find this very helpful having the lat lon up there. So we're going to do a true color mosaic, and I'll just do a median pixel and we'll let that run. Now, occasionally, just depending upon how many people are running simultaneously or how much activity is on the system, sometimes these mosaics will take 30 seconds to produce. Other times they may take a minute or two. So that one just took about 30 seconds. So what we see here now is this is a mosaic that is a true color mosaic. Median pixel, which means it takes the middle point of all of the data for each band, and it's for 2017. So what you're seeing here in the middle, this brownish area, is the city of Dodoma, and this is the surrounding region. And if I wanted to do something with this mosaic and I wanted to take it and analyze it, I come over here to the results tab. And if I click on the results tab, it tells me more about what I just created. It says, this is the time that I submitted the job. It only took a minute to run, less than a minute, because the clock is the same. Here's the lat long range. It's a 2017 to 2018 mosaic, median pixel, and it tells me a little bit about that. If I go to the output tab and I click on the output tab, it tells me a bit more. It tells me that there are 22 scenes, 22 time slices that make up this scene. This tells me the number of pixels that I chose. It's 100% clean, which means there's no clouds in this image. And then finally, now that I've clicked on this output, once you click on the output, you have a few choices down here for downloading. You can download the mosaic PNG file, which is just the image you see on the screen. If you chose a time series animation in the beginning when you set it up, you can create an animation, but you have to flag that in the filter in the beginning. And this one's probably the one you'll use the most. If you're doing an analysis outside of the user interface with like ArcGIS or QGIS, you'll probably want to download a GeoTIFF. And if I hit download select, it will automatically start downloading that to my screen. So I'm going to go back here and stop at this point and just say that there are a number of things that you can create with these custom mosaics. And this one here is maximum NDVI, so it's a very green mosaic in this case. So if I come over here, instead of median pixel, I'd run max NDVI. It'll take a bit longer to run, but in this particular case, you'll get a slightly different result. And you can see what that looks like here. It's quite colorful and much greener than the true color image. So I put a few comments in here on things that you want to think about. NDVI mosaics take a bit longer. The true color image you see on the screen tends to be a little darker than normal. If you pull that off into another code like QGIS, it brightens up quite a bit. And the output tabs, you can get these results. So the next thing I want to show you is just spectral indices, because these tend to be a little bit more interesting if you're looking at some detail. So let's go back over, and I'm now going to do land spectral indices. And again, I'm going to select the Tanzania cube. So now what we're going to do is we'll zoom in on this Dodoma region, and what I'd like to do is look at one of the spectral indices. So in this case, I'll do an NDVI plot, which is a vegetation index. So if you're interested in some agriculture in a particular area, and let's just say I take this area that's just to the east of Dodoma, and it's a small area. So I'm just running small plots here because you don't want to get too large. They'll just take a bit longer to run. I'm going to run a median pixel mosaic for my NDVI, or I take that back, I'll run a max NDVI. So I'm going to do NDVI. The compositing method I'm going to use is maximum NDVI. So it's going through the entire time stack when I pick the time in a moment. And I'll do that now. I'll take Landsat 8, max NDVI, and let's just do this for 2017. So what I've set up here and then I'm running, and I just hit submit to let it go. I'm looking at NDVI is the index that's going to be plotted on the screen. Maximum NDVI is the compositing method, which means it's going through this date range of 2017 January to January 2018, 1 year of information, and it's taking the maximum vegetation index of every pixel. So what we'll show on the screen is going to be, if there's vegetation in that area, the greenest it ever was during that year is what you will see on the screen. And this is often an interesting way to look at agriculture, because sometimes we want to look at the peak cycle, the peak vegetation index, Other times we may just want to look at the most recent pixel, or we want to look at the median or middle. And you can see this is running down here. It takes a few minutes to go through because it's doing a few calculations. It's taking all the band information and it's taking the NDVI equation and it's creating NDVI and then it's filtering. And now if you zoom in, you get a very nice colorful picture here. And so what I have on the screen here is this is the area. Again, we are just to the east of Dodoma, a very green area, quite a bit of vegetation. So very dark areas of vegetation like down in here are typically trees, forests, and areas that are lighter are your grasslands. And you probably have a little river running through the middle there. So if I were to take any one of these spots, there's a few things that I can do, and this little eyedropper on the left is extremely important, and I find it quite interesting. If I take this eyedropper here, I can place a marker at any place in this result, and what it's going to do is give me a time plot of that particular pixel that I'm on. So that pixel that I just clicked on, here's the lat lon in the top right-hand corner, is for this particular spot is the lat lon. So that particular spot, what it does is it takes a moment and now it plots out here to the right. So what you see on the right are these two-dimensional plots of what the vegetation index looked like. And what's really interesting about this particular spot in 2017, and this is just 1 year, and it shows all the indexes here, but the ones I'm looking at that are the most interesting are probably vegetation index and enhanced vegetation index. Notice what has happened. You get a green up cycle where it gets very high NDVI, 0.5, 0.6. This is probably a grassland area, because if this was forest, it would be 0.6 to 0.9. At most of the year, it's 0.2, which means it's fairly dry or brown grass. But at the spring period, which this is probably around March or April, must be your rainy season, this NDVI peaks at 0.5 to 0.6. You can also see it down here at Enhanced Vegetation Index, and this is the month scale along the bottom. So if I go to a different spot and just show you down here in the forest what this looks like, let's go down here to this dark forest and I will rerun the same thing. So it'll take just a minute to update on the right-hand side. We'll give that a second. So again, that is a darker vegetation location down on the right. And what you see down here on the right is something a bit different. So in this particular case, I thought this is interesting. I expected this to be a forest, and I expected it to be about 0.6 to 0.9 for the entire year, and it's not. So what that's telling me is this particular area has a peak vegetation index 0.6 to 0.8 in the spring season. So for about 3 to 4 months, there are periods where it has high vegetation. I'm not sure about that number right there. It's probably cloud contaminated. And then what happens during your dry season from about the middle June forward, it's back down to low NDVI around 0.2. So you can look at a number of things just pixel by pixel about what's happening in these areas, and it allows you to really get an idea of some of the variability in these spots. So this is a spot over here. It looks like there's some fields and some forests or some agriculture plots. So I find this interesting. Look at this one here that I just clicked on this spot. What you might see here, you might say that perhaps this is land degradation, perhaps this is just something where the field has changed over time. Again, your rainy season in the spring, the vegetation peaks, and then it slowly degrades throughout the year during the dry season. And by the end of the year in December, it's back to 0.2, and then the rains come. So I'm going to stop there. I'm going to jump back to the document and say there's a number of indices that you can do. There's a plot that I ran right here, which I thought was very interesting. I picked a spot here. This was near the lake, Salunga, just to the west of you. And it had a very high peak NDVI in the spring. It fell off dramatically into the dry season, and you can do this for any location. So I'll stop there and just first ask for any questions from you at this point before I move on to the Jupyter Notebooks. Any questions out there?
Brian,
Yes.
The analysis that you made, can you make analysis? Is it possible to make an analysis with a larger area than where the point is?
Sure. Yes, you can definitely do that. So let's say, but it just takes a bit longer doing it in the user interface.
Okay.
What I would prefer is if you're going to do larger areas, it's better to do it using the Jupyter Notebooks, and you have a number of those here, and I'll show you those in a minute. But when you do it in the user interface module, let's just say I'm doing NDVI for this much larger region, you see, because Tanzania, big place, right? Very big place. And if I'm doing, a spot that large, which is, about a third of your country in terms of north-south, it just takes quite a bit longer in the user interface. It will work, but when that task runs, it's just going to take quite a bit of time. So it tends to run faster if you use the Jupyter Notebooks to create these products. Does that answer your question? It will run. It's just a bit slower.
Yeah, sure. So you suggest if you are making analysis to go with the smaller portion so that you finish the smaller portion and then you go to the other portion. Is that your suggestion? Than
Yes.
taking the larger area at once?
Exactly. If you start with a large area, you will likely see that you'll run into some issues. So let's just say I'm going to go over and I'm going to do custom mosaic for Tanzania, and I say, all right, I just want this whole big area right here. That's a pretty big area, right? And I want to make this mosaic for, we'll just say we'll do Landsat 7, and I want to make a mosaic for the year of 2013. But again, this is a big area. So there's the year 2013. I'm going to do a most recent pixel true color mosaic. And it says here, task is greater than 1 square degree. So if you pick an area that's greater than 1 square degree, the user interface tool will say, oh, that's a bit too large. I can't run that. You can run those kind of analyses through the notebooks. I'll show you how to do it in a moment. So the user interface limits it to a smaller area, 1 square degree. And again, that's just to make it run faster. So if you want to do anything larger than that, I would suggest you do it through the notebooks. Because if you set up a really large area, I'm creating a vegetation index geotiff that's multiple degrees and a very large area, like so let's say I want to cover this entire national park. I could do that, but I might have it run in a Jupyter notebook and it might take 30 minutes or so to run, and then you'll come back later and the job will be complete and your analysis is ready. But if you do that in the user interface module, it tends to stall quite a bit and it will not complete. So there's already a limitation. I'd forgotten about that, but there's a limitation on 1 degree by 1 degree in terms of these analysis cases that you're running. So it's just something to consider.
Okay,
I'll show you how to do it in Jupyter Notebooks in a minute. Any other questions?
Okay, thank you, Brad.
Sure.
My interest is if I can perform the analysis maybe 3 times a year. For example, if I want to analyze from January to March to April, or something like that, is it possible? Because I've seen that
Sure.
is based upon 1 year, 2005, whatever. So.
Right. So here's something I really like to do. So let's say I want to look at a farming plot. And let's just say I know that here's Dodoma. Let's just say there's a farming plot right outside of here. Let's say it's right in this area here. And if I wanted to look at that area and say, I know there's some farming plots here, and I wanted to look at every 3 months, you do that in the bottom down here in your time scale. So let's just say I've got vegetation index. I want to take the median. I'm going to take some sort of an average, or it's a middle point. but I just want to do 3 months. All I need to do is select those 3 months over here in the left-hand side of the, so I first click January 1, 2017. I come to the end date, and I go back with this back arrow in months, and I go back to April 1. So this is running January 1, 2017 through April 1, 2017, and this is doing the 3 months that I want, and I want an NDVI. So again, I can put in the lat/lon bounds by hand, or I can do it with the box. You can always go in and put these by hand. So if I submit this, this is running an NDVI product. Look how fast that ran. It's 3 months of data. But here's what's going to happen with 3 months of data. Sometimes you're going to get clouds, and if you're running this during a rainy season, it may not be great. But you can see it does create this image. I can go to the Output tab. I could click on the Output tab, and I could download the GeoTIFF. So that creates my 3-month image for January through April. Now let's say, okay, now I want to create another one, and I want to go from April 1 to May, June, July. So I do 3 more months. Here's April 1 to July 1, 3-month period, same exact product. I hit submit. Let's see how quick that one runs. Very quickly. Notice the vegetation has changed a bit. And if I come over to the Output tab, they're both there. So this is the job that I ran here. And if you go through the Output tab, it says, here's the months, January through April. It was 97% cloud free because remember there was that cloud down in the corner. And it tells you there were 4 scenes, and it will allow you to download that GeoTIFF. I can also go back to the Output tab. Let's go back here. The other one, and I see this one's the April to July product, 98% cloud free, 2 scenes. There are fewer scenes, but you're looking at it, and again, you can download. So you can create any number of small windows. So you can do a little 3-month, 3-month, 3-month. You can compare year to year to year for just a few, your growing season. So you can do this on the fly quite rapidly and then pull these bits of information out. Does that answer your question?
Very perfect. Thank you very much.
Excellent.
And that's what I wanted to.
Ah, fantastic. Yeah, I have that question quite often because a lot of people have, very particular, let's say, farming areas or agriculture plots, and they want to look at the historical situation. And this is really nice for doing that. So yeah, it's a good way to do it. So
Another question, sorry.
Yeah, sure, go right ahead.
Yeah, of course, we African anyway, and most of the time the experts cannot make a decision. Of course, the decision always depends upon the politicians. And of course, we know the interests of politicians. And once I'll be discussing this important information, they will ask me, may be a critical question, but of course, we have the answer. For example, if a political person, if may ask me a question and you want to compare maybe one constituent to the other, that you would like to identify those farmers who have maybe planted different crops. For example, maize, cassava, cotton. How can we now use this technology and make sure that maybe from one district or region, this region managed to plant maybe different crop from the other? Is it possible to have that information when using this technology?
Yeah, that gets a bit more complicated because now what I believe your question would be, how do you identify different crop types? And that gets a little tougher, and that tends to be something you do. One of the notebooks that you had in the training, I don't know if you saw it, but there's a notebook that we have that does land classification. It does something called clustering. And what it does is it clusters pixels that look similar to one another. And it will allow you to classify those different kind of pixels. So for instance, if you're planting maize in one area and cassava in another area, these might look different at different times of the year, and you will be able to classify them and see them separately. So let me ask a deeper question, and that would be, are you trying to figure out where the different crop types are in a region, or would you? I'm just trying to guess at what particular question you would be trying to answer. You know, trying to optimize the crops, or are you trying to figure out the extent of the crops? You know, how much maize is planted in a particular area, how much cassava is planted in a particular area. Is that the question?
Yes, because, you know, it is a shame sometimes if you'll be asked maybe sometimes that why are we starving? Why we have enough land? Why we have people who can maybe plant various crops. So if we can manage to identify that, for example, this district, most of the people have planted maize or cassava, and then we should expect maybe the country won't suffer maybe without having food and whatever. So we want to find the best way on how we can predict it. But this time we have enough food because people have cropped a lot. Something like that. Yeah. And maybe is it possible maybe now to run either supervised classification or unsupervised and make sure that, okay, what do you want to find out? Because we don't need to get into stuff while we have the technology that can predict the future.
Yes. So if you knew the variability of an area, so let's just say this particular area is croplands. If you were able to tell areas that were corn, areas that were, you know, cassava, and perhaps how that changed from season to season, that would probably be valuable, correct? Yeah. So what I'll do is we have a notebook that does an analysis that basically it's called it's a clustering algorithm. It clusters the pixels into common types, and it will allow you to determine these clusters and the volume and how much area they occupy. What you need to do it correctly is you need to have a little bit of ground validation information. So for instance, if I know an area is absolutely maize, then when I get my clustering answer, I want to see how much of that area is maize and how much of it is a different crop. And so we've been testing that. I'm going to try to find one of our notebooks here. See if I can find one real quick, because we were just running one. Here's a clustering notebook that we ran. I just want to show you what it looks like. So I have this on the screen, and did I run it? Here's a clustering notebook here. So here is an area here, and we cluster by this thing called k-means classification. And here's what it looks like when it's done. And maybe this is what you're talking about. So this particular area, what it has done is it has classified this area into 4 different land classes, and it clusters them according to similarity in pixels. And what it does, it tells you the amount of area occupied by each one. So if you knew this area in yellow was maize, now this obviously it doesn't look like a cornfield or you know, it doesn't look like a vegetation or a agriculture plot. But if you knew this was maize, and you would know that all these other pixels are likely in similar maize, this is the amount of area that's maize. And maybe this blue area is cassava, you would know that. You could also go and pick cluster into more land classes. Here's 8 land classes, and here's 12 land classes. So it gets more complicated, but what you can do with a notebook like this is use this classification data to look at the areas that are occupied by similar pixels. And I think that's probably what you're going to want to do. I will, as a follow-up to this telecon, send you this notebook. I'll try to find a particular agriculture plot area and see how well this works, but I'll send that to you shortly, okay?
Okay, thank you.
So now I'd like to, if there's, are there any other questions on the user interface?
Okay, Brian.
Yes.
Will it be in the Jupyter format, or you send something like which is in, I don't know, because if you can send us, then we can try to overlay the smaller the administrative boundary that we have and see what is really happening on the ground. So will it be in the Jupyter format, or I don't know?
Yeah, I'm not sure I understand your question. Are you saying, so what I was thinking as a follow-up to this last discussion, I would send you a Jupyter notebook, which is going to be in this folder right here. This is your Jupyter notebook folder. I would give you a new Jupyter notebook that might be like called something like land clustering, and it will allow you to run these cluster analyses at any spot in Tanzania and interpret those results. Would that be acceptable?
Very fine. Thank you.
Excellent. And I'll do that as a follow-up, but any other questions on the user interface? Because I'm going to jump over to the more powerful stuff here, which is the actual notebooks.
More powerful.
Yeah, it's definitely more powerful because there's a lot more flexibility. You know, what we put into the user interface module is something that it's kind of quick, it's simple. There's some tasks I love to do in the user interface module. They're really easy to generate products. But if I really want power, I come into the Jupyter Notebook area because I can do a lot more. I can create products. I can create more complicated analyses. So I'm going to show you those today.
Thank you.
So let me go, and I'm going to start into this Jupyter Notebook area. In your document that I sent, at the top of step 2, it says ARDC Jupyter Notebooks. This is the website address, and this is the password for your Jupyter Notebook area, and I am in there right now. So I think I'm there. Yep, that's the right one. So if you go there, I've just recently cleaned this up. And what you have in your notebook area are the notebooks you see here on the screen. Remember the 6 that we covered in the training session in Nairobi, they're down here. So we have mosaics and water, indices, all those are there. Those were the training notebooks from Nairobi. Everything on the top here are new notebooks that I've recently added that I'm going to go through a few of these today, and I think you'll find them quite interesting. So I'm going to run for you live. We're going to do 3 of them. I'm going to start with this one called Cloud Statistics. This is a new, these 3 notebooks I'm going to demonstrate for you are brand new. We just put these together. I think they're going to be quite valuable. So follow through with me as I show you. So the first one's Cloud Statistics. It calculates statistics for a region, looking at either Landsat 7 or Landsat 8. It's going to show you all of the time steps in your data and the cloud percentage. It's going to display it in a table. Then it's going to give you a time series plot. So let's see what that looks like in the code. So I have the tab already opened, Cloud Statistics, and I'm going to walk you through the notebook to show you how this runs. If you're not sure how to run the notebooks or use these, I urge you to go back to the African Regional Data Cube training that we did in Nairobi. There's a section in that training manual that teaches you how to run this, because if I want to run this whole thing, I do kernel restart run all, and it runs the entire thing. If I want to run individual lines, I do shift return. There's some subtleties that you need to know, but this is how you run these. So let me walk you through this data. This is cloud statistics. I start at the top. I import some data cube stuff. You don't modify any of this. It's just, it all runs. I've run all of these on your site and they all run fine. First thing I do is I load in Landsat and I say, all right, what are the Landsat data sets? Here they are. So you can actually see Ghana and Sierra Leone and Vietnam if you wanted to, but that's not helpful. But the good news is Tanzania is there. Tanzania is in the Landsat 8. The next thing I do is I say, show me the extent of these cubes. So I print out the extent and I say, okay, if I'm going to use the Landsat 8 cube, it goes from 2013 to 2018 so that I know what's in there. Because when I run an analysis, right here, the product I've selected is Landsat 8 Tanzania. There's the extent of the cube. So I can only do an analysis between this date, April 12th, 2013, and January 2018. I can't pick a time range outside of that window. So I'm going to do an analysis that says I'm interested in how cloudy is the data, because it's a measure of, you know, how much data am I going to have for this area here near the East Shenane Forest. I don't know if I'm saying that correctly, if it's Shenane, but this is a forest area in Tanzania that I've done some analyses. I'm going to look at all of the data for 2017 January to January of 18, so a year's worth of data. And when I run this, you don't modify anything here. Here's what is resulting is this table. This table says I have 0 to 21, so there's 22 scenes. But what's happening is a few of these scenes, you'll see they're all scattered about, pretty much all throughout the year, but some of them are terrible. So this one here, 0 clean pixels. Even though the scene is available, it's completely cloudy. This one is 73% clean, 100% clean. So on February 11, if you wanted to look at that particular image, it's very clean with no clouds. So I come down here and I look at, this is the time series plot of all that data. So the ones at the top are 100% clean. So only these scenes are really good. These scenes in the middle have scattered cloudiness. And notice what happens, and you'll probably see this in many of your images. In March through May, there are very few clear scenes. I will bet that is your rainy period. Am I correct? March through May?
Yes.
Yeah.
Yeah. So you have a problem getting optical Landsat data in these couple 3 months. It's going to be difficult. One way to solve this in the future is we're going to be bringing radar data into your cubes. And in times of the year where you have lots of clouds and rain, we might try to use some radar data to get some information. But you see, other times of the year, I get scenes, but this is a very bad time of the year. So I can look at an individual time slice. This is index 1. If I go back to the list, that is looking at this scene right here, which is 73% clean. This is the index down the left-hand side, index 1. So I can change this right here to index 2, and I hit shift return, and it replots, and that was a clean one. So remember, index 2 was 100% clean, but let's go over to this one right here, index number 8, 57% clean. You're going to see a lot of clouds. So I hit 8, I hit shift return, it reruns, and notice all the clouds. Lots of clouds on the left, some clouds on the right, looks like some cloud shadow. Not a great image. So if you want to look at data image by image, one by one, this is a good tool to do it. If you want to evaluate your cloud situation, because you may be wanting to create a mosaic from March through May, and you're wondering why you can't create a good clean mosaic, this is the problem. There's not many good pixels. So this is a good way to look at data. If you wanted to run this whole thing and change the date, I could change this, you know, to 2016, And then I could, if I'm done, if I change a few things in this, I go kernel, restart, run all, and it just runs top to bottom through the entire process. So let me do that. I'm going to let one run while we hop on over to the other side. So let's just say I want to run a new year. I'm going to run 2016 to 2017. Same thing. I'm going to run the whole thing. I'm just going to come back, kernel, restart, run all. I'm running this on the fly, and here's what you'll see. It jumps to the bottom, puts little stars. When stars are in the box, it means that this block has not executed yet. If I just scroll to the top, I can watch it execute. It's already executed this one and this one. It's executed number 4 because it puts them there. It executes number 5, and now look what happens. It stalls here on this block because this block is loading in the DataCube API. That takes a bit of time to do, and then it's going to start doing the analysis. So right here, it's loading the data, and that's what it's doing. It's loading in this product. It just did it, so it hopped. Now it's going to jump quickly to the end, and if I scroll down, everything's run, and there it is. So this is all of the data for 2016. Now let's look at the plot and see how it's changed. Notice the difference. This is kind of interesting. In 2017, you had no good data for March, April, May. This period right here was terrible. But in 2016, I have a couple good scenes. This is actually pretty good because here's a scene here, here, and here that are fairly cloud-free, about 80% cloud-free. So let's look at one of those scenes. I'm going to look at scene number 4. So if I come down here and look at scene number 4, index number 4, and I hit return, I can see that there's clouds and cloud shadow right in this portion, but most of this scene is fairly clear. So you can kind of get an idea as 2016 is a better year, you have much better data, but 2017 was really bad for those 3 months in the spring rainy season. So I'm going to jump over and go into another new notebook called NDVI Phenology. This one is completely brand new. I want to credit one of our team members, John Ratz, who's on the line, who helped put this together. I think you're going to find this extremely valuable. I have been very impressed with the output on this notebook, and let me guide you through it. So the first thing we have to think about, phenology is the study of seasonal variations in agriculture. So that's very important. If I'm looking at agriculture, I would like to know, how does a plot of maize or a plot of cassava, how has it greened up and been harvested over time? Can I look at that dynamic? And this is going to allow you to do this. This cannot be done in the user interface module right now, but that's the power of this this notebook. So let me show you this. So NDVI Phenology, it uses NDVI. So NDVI is, vegetation index. It's basically the greenness or photosynthetic activity. I give a little description here of its relevance, and I can run this code on Landsat 7 or Landsat 8 over any region I want. In the end, the products are really impressive. So this is a grassland plot in an area in Tanzania in the north. It's northern grassland. This is the example I put in the document. And I'm going to show you these output products. One of the output products is this one right here on the screen. I'll make it just a little bigger here so that we can see it. What it's doing is, for this particular plot, it is binning all the pixels. And by binning, what I mean is I gather the data from all of the pixels and I put it into a box and whisker plot where the middle of this box is this little orange line is the middle or the median of the data set. So for instance, this one is binned up by this particular product is 4 years from 2011 through 2015. And it's showing you the peak growing cycle each year, and how in some years, like this year was a bit greener than this year over here. these years was a really nice growing cycle. You can see when it starts to green up and when it's harvested and falls down. And this is the period of maximum greenness and when the harvesting occurs. I'll show you that in a moment. And the last one, the kind of plot you can do for this phenology is if I bin up all of the pixels for all of the years, so this case I'm doing all 5 years together, I could do a monthly plot. Here's January, February, March, April. So this is your rainy season. The greenness peaks. And then after the rainy season in May, June, July, this is the downturn of your vegetation index, and this is your dry season. So if you're looking at phenology, what typically happens is this is the portion of when the planting occurs and the planting starts to peak. You can learn more about, the peak. It peaks in the February, March, April timeframe. This is when you'll be harvesting. And then this is the period of the dry time. You can look at different crops and get an idea for how maize has responded in different times of different years. You can do this year by year by year and look at, well, what happened in 2011, what happened in 2015, what happened in 2017. And if you do this over a plot, you can get a lot of interesting information. So I'm going to go back to the notebook just to walk you through what it does. So the notebook that I've set up for you, again, if you go to your home site, this notebook here is NDVI Phenology. I have it open and it's running. So it takes Landsat 7 and Landsat 8 data. This is one of the powerful things of the notebook that I really like, is that it's using data from both of these missions. You can tell it not to use from one or the other. Right here is in this block here, it says use Landsat 7 true, use Landsat 8 true. It is using both of the missions, but you can turn one on or one off and use one or the other. Next thing it does, it gets the latitude, longitude extents. Here it says, okay, I'm loading up a data cube for all of Tanzania. The next thing I want to do is I have to pick a region. So this is where you specify the region in this block. So I have a northern grassland, a southern grassland, and an area near the Swaga Game Reserve. These are just 3 areas that I picked randomly. I just was trying to find grasslands and croplands to show variation. And this is what you get. This particular one was a grassland plot. And if you zoom in, you can see all the details of this grassland plot. And you can see it definitely looks like controlled grasslands. And if I go through and look at the data, just like you saw here, the very last plot is this plot, and this is the month of the year. So I'm binning here by month of year. If I wanted to change the output, it gets changed right here. And you can see in here can be one of week, month, week of year, month of year. So this is month of year. Let's say I change this to week of year and I hit shift return. It's going to redo the plot rapidly. And there it is by week of year. So for this grassland region, this is binning up all of the pixels. And it basically says that the peak vegetation is everything. I would say it starts in maybe late December, and all of this is peaked through about May. And then the downturn in your grasslands, and this is the dry period where there's little variability. There's more variability up here, but this is definitely peak greenness. And so this is the period where if you're going to use these grasslands for cattle, if you're going to use these grasslands for some sort of a harvest, this is the period where it peaks. And you can compare this from year to year. So this is week of year, month of year. If I just did this month, this is going to show month. And I plot this. This is going to show monthly binning of all of the years. So now it's by month for every year split out. So when you bin things, you pull the months together, or if you can separate them, you can separate them into weeks and months. The weekly plot gets pretty crowded. Let me just show you how to rerun this for a different area. So let's say I'm not interested in this area, but the area that I want is I'm going to show you this southern cropland. I will comment. So a comment is this little hashtag. I comment out that line, and I remove the comments from the other line, because this is the lat and longitude region of this southern cropland. So this is where I add new areas. I come back to the end, and I'm going to run, this is 2011 through 15. I'm going to shorten this up, and I'm just going to run I'm going to run 2 years. I'm going to run 2015. This is basically Landsat 7, this is the start dates of the two data sets. And then I'm going to run through 2017 through end. So it's going to run all 2015, 16, and 17. We'll run, let me just do 2 years, 2016 through 2017. So this is where you change the time. This is where you change the region. I'm going to do kernel, restart, run all, and I'm going to let this run. This one may take a few minutes, but while it's running, we'll go back and I'll look at the document to show you where we're headed next. So I'm going to let this run. See the stars? The stars are saying it is executing, and it's executed pretty quick up to this point right here, because this is the point where it loads in the Landsat 7 data and it loads in the Landsat 8 data. That's where you'll see it stall, because again, it's going out and retrieving the pixels from the Tanzania cube and getting the information it needs to perform the analysis. So if there's a star, that means it's working on that block. So I'm going to go over here while this is working and tell you about the next thing we'll be doing is we're going to work, I named that one wrong. That's not supposed to be phenology. I'll fix that. That's supposed to be NDVI anomaly. And that's the next one we're going to run is NDVI anomaly. So while this one's running, it just loaded up Landsat 7. So see it, the block filled in a number 5. That means it has loaded up the Landsat 7 data into memory, and it's now working on the Landsat 8 block. So if you're impatient like me, you just watch it run and you check on it as it goes and keep an eye on it. In the meantime, I can come over and we're going to start to look at this NDVI anomaly. We'll come back to the phenology one, but let me go walk you through anomaly. The NDVI anomaly is a very interesting one, because this particular notebook is going to allow you to detect land change. So here is how this one works. It's very similar to the other notebooks. Loads in, you know, the setup for the data cube. These three things say, load up my data cube products. What do I have for Landsat 7? What do I have for Landsat 8? I pick one of them. In this particular case, I'm picking the Landsat 7 product. I show the time extents. It says it goes from 2000 through 2018, so I have a lot of data to choose from. And what I'm trying to do here is I'm trying to show land change and anomalies in the land over time. I'm picking an area here that's been deforested because I did this for, I don't know if someone's on the line here. I think I might have done this one for Benedict before for the Shenane Forest. So in the eastern side of the forest, this area has experienced deforestation. So here's the lat lawn area. I picked my lat lawn area. Along this edge here, here's forest and here's non-forest. Along this edge has been a lot of deforestation over time. So this is the area of analysis. I'm going to go down and I'm going to do a few things. One of the ways to detect deforestation, a simple way to do it, is to look at vegetation index. We know that forests have a vegetation index that's high, typically 0.6 to 0.9. So if the first thing I do is I select a baseline time period, I say I'm going to start with my data in 2004 to 2007. I'm going to compare that to 2013 to the start of 2014. So I'm going to say, give me all the data for 2004 to 2007. I'm gathering data over 3 years because if it's cloudy, I want to make sure I get enough clear pixels. And then I'm going to compare it to about 10 years later, 2013 to 2014. So that's the baseline period, that's the analysis period. I am going to choose a mosaic type. The one I like to use is maximum NDVI. So max NDVI says I want to take the peak vegetation, because if it's forest, it will be between 0.6 and 0.9. So that's my threshold for the baseline. I am only going to consider pixels for my analysis in the range of 0.6 to 0.9. So next, I've got that all set up. It loads in the data. None of this gets changed here. This is all just logic for cleaning it up, getting rid of clouds, creating this mosaic. And in the end, here's my baseline mosaic and my analysis mosaic. So here's what happens. This is the RGB output. This is just red, green, blue of my baseline. Lots of forests. And I go here and now I see this is the analysis time 10 years later. You'll see a bit of change. It's not very obvious here that there's been deforestation because these RGB plots are not the greatest. They're a little dark on the screen, but the underlying data will tell you it has been devegetated and deforested. So let's look at the output. By the way, the phenology is done because there's no longer an hourglass there, so this one's done. We'll go back to that in a moment. So the NDVI threshold range, remember we said I'm only going to look at pixels that are between 0.6 and 0.9. So the very first thing you get is a plot that says in that window, which of these pixels are between 0.6 and 0.9 and which are not. The area down here to the south in white are areas that are not trees. The area here to the north is all trees because it's between 0.6 and 0.9. So basically it says, I'm putting a filter on it. I'm applying my NDVI filter and I'm masking out the pixels that if it doesn't fall between 0.6 and 0.9, I'm not going to consider it in my analysis. So I'm only considering things in dark green. And now I'm going to show you the results. This is the anomaly plot. This is saying the vegetation change between 2004 and 2013 is this answer right here. If vegetation has gone down and been deforested, it will be in the yellow and red. All of this area has changed its vegetation and reduced. Now, what you might say up here is, here's a little bit of green. This actually increased vegetation a bit, but quite minor, about 0.1. These areas in here have had some small reduction, around minus 0.1. But the areas that are dark, this area here, here, and these areas here are highly likely deforestation because the vegetation index changed dramatically. So these are non-forest. I can look at it in another plot where I bin them up and I bin them in chunks. So you can change this, levels 8, I could change this to levels 12 and make a 12 bin plot. But the idea here is that this area is likely deforestation, this area and this area. This next one says every pixel that was negative is in red. Every pixel that was positive is in green. This basically says these pixels up here increased vegetation, these pixels decreased. But they may not all be deforestation because it's likely deforestation are the most severe ones. And then finally, I create a threshold product and I say, the only thing I want to consider is I want to consider anomalies between minus 0.1 and minus 0.6 and show me those in that region. And here's what I get. So if I'm looking for, if I want to remove, so I go back to this plot, everything between 0 and minus 0.1 just could be a minor change in vegetation index that doesn't mean very much. It could just be the leaves on the trees slightly changed from one year to another, and it's not necessarily deforestation. But how do I capture these areas? They're likely between minus 0.1 and greater, and that's what I'm doing here. I am masking out everything between 0.1 and 0.6. Let's just change this to 0.2. If I go from minus 0.2 to minus 0.6, I'm going to rerun this section. So I'm just hitting Shift Return, and there's the new plot. And notice I get a little bit of scattering pixels here, here, and here. But what's interesting is this is all happening along the border of the forest, which when I had the communication with Mr. Mugambi, I believe he told me most of this deforestation was occurring along the border of the forest. So if I go back and change that threshold to 0.1, rerun these again, I'm just hitting Shift Return, you start to see clusters of, that is likely an area of deforestation, that's another area, that's another area. And in the bottom, when I go down, I can count this threshold, and what it's saying to me is that the percent area inside this threshold is 10%. So 10% of the pixels in this picture are red and have likely been deforested or significantly changed. So the way I would suggest you use this notebook is run this in areas where you believe there's deforestation or where you believe there's large changes in vegetation. Change these thresholds, and when you start to get pockets of regions like this one or like this one, those are the areas you would probably want to go investigate. And if you change the timing of this, you can go from year to year and rerun these. So for instance, if you come back to the end, go back to the beginning, I was comparing a baseline period of 2004, 2007. That was my baseline. And I was looking at 2013 or 14. If I backed up and just changed that to 2010 to 2011, I could see what happened in the first 6 years. I could change these time periods and see what's happened in just the last year. I could make my baseline 2010 and my analysis period 2011 and just look at the change for 1 year. So there's a lot of power here in, if you change the timing, you will be able to alter this notebook, and I ask you to go ahead, play around with it, try it out. So let me go back, since we're almost done here, and I'm going to show you the NDVI phenology plot that we ran. So remember, we were watching this run, and this one was set up to rerun the area. Let's go down. The area that I had chosen was this new area of southern croplands, which is right here. So here's the area of southern croplands. In here, you can see the fields. You can see how they're squared off, and a lot of fields. I don't know if these are grazing lands. I don't know if they're maize or if they're cassava, but it would be interesting for you to rerun this analysis over a spot that you know. So I reran this, and let's come down and look at the results. And here it is. It's a very, very interesting analysis. So look at this product. This product says, for this time period of these 2 years, I see that I get the peak, as I would expect, January, February, March, April, peak greenness, starts to fall off. Here's your dry season. Here is your growing season again. So again, sometime in December is when your fields begin to green up. They peak again. So not sure why this one's low. This is probably low because there's not a lot of data. Because remember, this is your wet season. So if there's limited data, this might only be 1 or 2 scenes here. So what you get is this peak. So this is looking at the full 2-year period. If I do month of year and change this plot to month of year and rerun it, this bins everything up to months. And again, for just this area, so that's all the croplands I was looking at, I can see this particular feature which says, this is my January, February, March, April green period. This is my dry period. So what's interesting is that, let's say you're a farmer or you're doing an analysis and you know that right here, this whole field right here is cassava. I might just want to do an analysis for a very small region that I know is cassava, and I want to look at the time history of this particular crop and to see how it responded. I can also compare crops to crops. I can do an analysis for a cassava agriculture plot. I can look at maize, or I could look at something else, and I could start to look at how the timing of the greenness peaks and what some of these are called phenological cycles. It's very valuable because they often want to know what is the start of season and the end of season for their harvesting. So I will stop there, and that's it. I have everything that I ran here today is all in the notebooks, but there's a few others that I added in the end. There's an agriculture spectral indices notebook. I'm not going to go through that today, but feel free to look at it. It's just if you want to create an NDVI or EVI plot for a particular area and output it. If you want to go back and look at my PyCCD that I did for the Shanine Forest, I urge you just be careful. That code takes very long to run, 20 minutes or more for an analysis case. And if you want to export GeoTIFFs or NetCDFs for Landsat 7 or Landsat 8 and create a custom export, and if you want to do all your analysis in like ArcMap or QGIS, these notebooks here, GeoTIFF exports, which are right here, this one, this one, this one, and this one, these 4 notebooks here allow you to do custom GeoTIFF exports so that you can take it into a different tool to do your analysis. So I'll stop there for if you have any questions about all of this, and I'd be curious to hear your thoughts.
Thank you very much. Ryan, can you hear me?
Mm-hmm.
Thank you very
I can
much.
hear you.
Ryan?
Yes.
Yeah, can you hear me? Okay.
I can hear you fine.
Yeah, so thank you very much for your time. And sometimes it seems as if we can have another session like this one, for us, might be very, very fine. But I don't know if you have another time maybe to have another session like this one. But otherwise, we have gained a lot. So maybe if there is any question from my colleague here, please, anybody.
Yeah, you know, I will offer. You alluded to doing another session like this.
Yes.
What would be helpful for me to help you better is if you have a particular problem that you're investigating. Because what I showed you today was I just picked some random areas. I just wanted to show you the capabilities of these notebooks, but they're not targeted to a particular area where you're trying to answer a question. So what I would love to hear is if you have an area and you have a problem, some hypothesis, and you are trying to answer something for a political person, and you say, here's what I want to do. I want to find out how much maize crop I have in this one region, and I want to know how it's been growing in the last 5 years, and whether climate change has had any impact on this crop. Those kind of particular questions are helpful because we can then tailor these notebooks for you and run an example or two and help you out so that then you can continue the work on your own, but you'll have a better understanding. So feel free to let me know if there's a particular problem in a particular area of interest. That would be very helpful.
Yes, but of course, in a connection to that one, and after this presentation, I wanted also to ask how can I differentiate between deforestation area and the area of which we think in the future may be affected or may become a desert area.
So land degradation.
Verified, yes.
So
Information is very, very important for us. Of course, sometimes we ask those people who can make decisions, and they'll be appreciated if they can have
right.
idea. Yeah.
So this NDVI anomaly notebook is an area that could be used to show land degradation. The way you would see that is this anomaly right here. If I took a baseline period, let's just say hypothetically, I am looking at how has this land degraded in the last 5 years, and or maybe even 10 years. If I ran just this notebook over the region, if land is degrading, its vegetation index will be decreasing, and what you'll see is many of these orange and reds in the final product. Now, land degradation can be a bit tricky, right? Because it could be deforestation, which is pretty severe, and it's easier to find because it's big losses, like, average vegetation drops dramatically. But what you might see is small changes in vegetation over time that says this area is getting drier and drier and drier over time. And those might be these areas here that are just, 0.1 to 0.2 of loss. But what you want to do is compare multiple time periods. And the way I would suggest doing that is maybe you create a maximum NDVI for year 1, year 2, year 3, year 4, year 5, and then you compare the maximum NDVI between each one of those years and see if it's continuing to go down on average. That's basically what land degradation will be. There's more to it technically, because if you read the manuals from the United Nations, one of the Sustainable Development Goals, 15.3.1, is land degradation. We're going to be developing a notebook in the coming months that tries to target specifically land degradation. And so this notebook I built you here has many of the features, but it's a little bit more targeted to major changes like deforestation. I think it would be valuable to create a land degradation notebook that will allow you to look at just these NDVI features over time to see how things are changing. And I did one recently. Let me see if I can find it on my desktop. I did one for a refugee camp in Kenya. Let me show you an example of a refugee camp in Kenya. This one was interesting. So this is in Dadaab. I don't know if you've heard about these refugee camps, but they're near Somalia. So this area here, the Hagadera refugee camp, 100,000 people live here. And the area surrounding this used to be green and forested, and over time they have deforested and devegetated this for their own use. And here's what it looks like. All I did, I used the user interface, I used the online user interface, and I created NDVI, maximum NDVI for these 5-year chunks. And look at the difference. It's really obvious here. And all I did was use the UI to do this. Let me just make this a little bigger so we can all see it. This is year 2000. This is the camp. And look at the surrounding vegetation, quite green. 2005, the camp is growing. The vegetation is reducing. Look what happened here. Much of the vegetation out here was lost. 2010, more vegetation lost in the surrounding area, and the camp is larger. And look at 2015. Very brown. They have completely lost the vegetation surrounding the camp. So this area here has been desertified, I guess it's called. It's desert land now. Whereas in 2000, it was highly vegetated. is that basically what you're getting at? This land degradation. You can visually see it here. Is this the kind of information you're seeking? Does that make sense?
Yes, it makes sense a lot, because we think maybe even in Tanzania and Dodoma, there are some of the area of which you think maybe it goes degradation very, very rapidly. But we have no any data like the images that we can see now, or the evidence that we can see now. So this is the thing that we have to develop and then show all these people that they look here. This is the way of how it was back some years, and this is now how it looks like at this time. Even though it's not, there's no any refuge, there's nothing there, but it happens. Maybe in the future we can have the desert area in Tanzania. So this is the thing of what we have to show. And
so let me show you. This is a really great use case. So let's say at Dodoma in the region. I'm going to show you how I would do this case for you if I were to do it myself. I would do two things. I would use the user interface to create the plots that you see on the screen. 2000. I do every year. I'd create an image like this, and the way we do that is I'm going to go back to your site right here, and I'm going to do this real quickly and show you how I would do this. I'm just going to go do spectral indices, Tanzania. Let's say I'm just looking at Dodoma, which is really nice, and I'm just going to look at the area around your city, just about that big. And I want to start with, the first one I'm going to do is I'm going to do year 2000. I do January 2000. I pick January 1. It increments it from January to January. There's 1 year. NDVI, maximum NDVI. So what I'm going to show you is the maximum vegetation for 1 year over that spot right there. Now, if I were doing this analysis, and I'd like you to do this analysis because I think you can learn from this. Look how quick that ran, right? Ran very fast. Maximum analysis. Now, I go to the output tab, click on this output tab, and I could download what I see on the screen as a PNG or a GeoTIFF. But let's go back, and I'm going to rerun this again for 15 years later. And I'm going to do January 2015, and there it is, 2015 to 2016. So there's 15 years later. I'm going to run it again. And we should see a change here, because you think it's been devegetated in a lot of areas, correct? All right, it is a bit drier, but there's an unfortunate thing here is Landsat 7 has these terrible bands through the data, which isn't great. If I wanted to clean it up, maybe I do a Landsat 8 pixel, Landsat 8 max NDVI for the same time period, because it's a little bit better. So let me just do that one. So I'm running these things pretty rapidly, and every time I run a case, it's going to save the output in my output tab, and I can go over to my output tab and I can download these and pull them into a document just like I did here. Everything I did here was done on the user interface. I just grabbed the PNG file and now I plotted it, and it's, does a nice job because it compares, you can just compare one to another max NDVI. All right, this one's still running. Give it a second here. This is running it's using Landsat 8. And while I have you on the line, I'm going to do the same thing for the NDVI anomaly. Now, it looks a little darker because Landsat 8 and Landsat 7 have a slight difference here, but there's probably some areas here where the vegetation has dropped. So anyhow, if you go to the output tabs, stick with one mission like Landsat 7 and just run 1 year of Landsat 7 every year going forward, and you can start to see the change in the vegetation indices. And then you can click on each one of these and download the PNG file and pull them into a document like this. Here's what I would like to do. I'm going to show you how to do this NDVI anomaly for your area of Dodoma. And let's pick, I'm going to go back since I don't know where it is. I'm going to use the user interface to show me where the bounds of the box. So the boundaries that I just used for this analysis, go back to my filters. I'm going to write down these 6.18, 6.167. I'm looking at the lat-lon boundaries, 35.777 and 35.8228. I'm going to use this box, and I'm going to go to my NDVI anomaly, and I'm going to create a new one here for you. This is going to be Dodoma City region. I'm going to copy this and paste it down here. I'm going to add comments here, and I'm going to change the lat-lon to the box we just worked on, which was, oh, by the way, are these negatives? Yes, these are negatives. Negative 6.167, 6.180. Just bear with me here, and I'm going to run this while we wait. 35.8228 and 35.777. This is now Dodoma region. We are going to compare, and I'm going to think of an analysis period and say, I'm going to compare from 2002 to 2004. So 2 years worth of data in the beginning. Let's do 3 years because, or actually, I'll just do 2002, 2004. So I'm going to take 2 early years and I'm going to compare it to max NDVI and 2 late years, which would be 2016 to 18. So this says I'm going to compare vegetation change from 2002 to 4 to 2016 to 18, which is a 14-year period. And I'm going to look at NDVI pixels. I'm going to look at all of them. I'm just going to look at a range of anything from 0.1 to 0.9. So it's going to take everything from forests to grasslands. And I'm seeing if anything else needs to change. I think that's going to be it for now. Later on, we can change the results. Let me, hold on, let me just save that. I hit the little save button and I restart run all. We're going to let this run. So what I have done for you right here is I have set up an analysis in a notebook that's running an NDVI anomaly that gets at the problem that you were talking about, which is I just want to see the vegetation change around the city of Dodoma over the years. And this is what it's going to do. Because remember, I'm going to be looking for something that looks like the following. I'm going to be looking for this right here. I'm going to be looking for if vegetation has reduced, the average vegetation peak has reduced, I'm going to see yellows and reds. Increases will be green. So if there is land degradation in these 14 years, you're going to see a lot of yellows and reds. Remember the black pixels. The black pixels are ones that do not fall within my threshold. For this particular case, I made a threshold of 0.6 to 0.9 because I was trying to cut out everything that was not forest. So this is non-forest, and I didn't care about it. You notice in the analysis I just set up that's running, I used a threshold of 0.6 to 0.1 to 0.9, I think it was. Go back. Let's go down. I used 0.1. Here's my region. Oh, I didn't do that region very well. I picked a bad region.
But you saved
All
the
right,
data.
I messed up. That's a wrong spot.
Oh,
Let me go back again and figure out why I got the wrong one. Hang on just a second. So up here, minus 6.1, down here, minus 6.255. I'm going to stop this for a minute. Minus 6.1, and what did I say? Minus 6.255. That was terrible. I didn't do a good job of. All right, there it is. Now I've just got to get my longitude correct. 3565, 3585. All right, sorry about that. 3565, 3585. Now let's see if it's right. There we go. I got the region right. There it is. We're going to be analyzing this region here. I'm going to rerun this whole thing. My apologies. I did a bad job with my bounding box. So, no, that's my problem. So we're going to get the main part of the city. So you could do this analysis for a larger area, but I just did a small one here so that we can get this to run. But basically what I'm going to look at is we're trying to determine, has there been land degradation in this 15-year period, and when and where has this occurred? And this is going to get at that. So again, the region I've picked is this Dodoma City region right here. I just thought, you know what, I had already loaded up the Landsat Cube. I could have started to just rerun the notebook from this point forward. That was my fault. I'm sure my team is probably rolling their eyes right now saying, Brian, you messed up. Because once you load in the notebook here and it's already in memory, you can start from this point forward and just run the rest of the notebook. So there it is. Here's the area we're analyzing. So it's got your central city of Dodoma. It's got some of the areas out here in the perimeter. Got some areas here that look like farmland, grassland. So this is all around, and now it's going through, defining the analysis parameters. So notice the threshold range I picked was 0.1 to 0.9. It basically says I'm taking all vegetation in this, 0.1 to 0.9 says I'm gonna be looking at everything. So something that's less than 0.1 might be water or a building, and something greater than 0.9. So I like to use a threshold range in the middle because every once in a while NDVI has some strange calculations, so you want to cut them out. And it's running pretty quickly. Here's the image before, and there's the image after. So you get some lines, the Landsat 7 banding lines. But I definitely see, you see this dark area here, which was early in 2000. Notice it's smaller here. So this area right here has been devegetated, and this area here was darker, much smaller. That's going to show up in the product. Now, dark green says these are all the pixels that were between 0.1 and 0.9. So basically, the very middle of the city right here has no vegetation, and a spot here, that might be a lake. Everything else had some vegetation at some point. Here's the answer. That is pretty impressive.
okay.
Now, remember what I said. Areas that are red are degraded land and vegetation decrease. And you can see this very clearly. Here's the center of the city. The only place that is increased in vegetation is out here to the southeast. But notice this area right here, probably deforested. This area probably deforested. So this is just north of the city, because if it's dark red, that's a big change in vegetation, and this area deforested. And you see quite a bit here of areas where you have some modest greens or red. But the bottom line is there's a lot of degradation. So let's look at how much of this area has changed. I come down here, and this bins it up into chunks. So you can see these big blocks here. That's deforestation, and that's probably deforestation. I'm not sure why that's regrown, but it has. The red in this plot, everything that has gone negative is red, everything positive is green. Quite interesting. There's a lot of red, and areas of deforestation show as big blocks. And the last thing I'm going to do is say, just show me everything that's changed from 0.1 to 0.6. And that, there it is, it's pretty large. Let me just look at just the largest ones, 0.2 to 0.6. There it is. So if I just classified for this 15-year period, vegetation that has dropped by 20%, so 0.2 to 0.6 NDVI change, this is the area that I get. The center of the city is here. This area here had a significant loss in vegetation. Same with this area and this area. These are likely areas of land degradation. Now, you do have some spots here that are bits and pieces, but if I count up the number of red pixels, it says in that area, 29% of the pixels fall within the threshold. So 29% of your land in the area that we just analyzed has degraded or significantly changed vegetation index in 15 years, 29% of that land. And so I've just done this analysis for you. I hope that gives you an example of the kind of analyses you can do, both with the user interface, which gives you some nice images to look at, and this notebook, which gives you the numerical product. Was that helpful?
Very, very, very.
Excellent. So that's the kind of thing I would like, you know, if you have a particular area that you're trying to analyze, you're not quite sure what the data means, you're maybe having a problem with the notebook, let us know. We'll help you out. And I think this is a very powerful story. This story right here for Dodoma tells me there's a lot of change happening around Dodoma, and that's an area here and here and here that had probably deforested and significant land change. These areas here might just be areas that are drier than usual, and maybe these are grasslands that are much drier, or maybe these are areas that have where the vegetation has been wiped out and they're just completely degraded. So it's a very interesting situation here. But I think, you know, a political person could look at this product and make some sense of it, you know, because you could look at this and say, areas here that are red have significantly reduced vegetation in the past 15 years. There's very few areas in green with increased vegetation, but overall, most of this is yellow and orange, which says the area here is much less vegetated in the 15-year time period.
Sure.
Any other questions or comments here? I hope you found that useful.
Some questions?
Brian?
Yes.
I'm curious to, from the presentation, we already know that there is a way we can export into the GeoTIFF and the other format where you can use.
Right.
Where we can use by using shapefile and other format.
Oh, you mean shapefile to get a particular region of interest?
Yeah, exactly. I'm curious to, before I do analysis,
right,
to know which am I doing analysis rather than using coordinates. Is it possible to add shapefile before
Yes. That's something we have done in another notebook, and we've had that question a few times. So we will work on that and get back with you on shapefile. So here's how I would suggest it would occur, and let me know if you think this is reasonable. In the area right here where you select an analysis region, instead of defining a latitude longitude box,
Yes.
what would happen right here is you would refer to a shapefile and it would pull the coordinates out of the shapefile. The key is that your shapefile must be uploaded into your folder somewhere here. So I might suggest to you that you make a new folder here, like I could do it right now, and I could make a new folder and I say, I'm going to make untitled folder, here it is, and I'm just going to rename this as shapefiles. So I have a new folder called shapefiles. In this folder, you would upload, see this little upload key in the top right? Upload, and you can upload from your computer into here shapefiles. Once I've uploaded this shapefile, as I am running my code here, we will put in some code that will grab the information out of that shapefile to determine the region of interest that you want. Is that what you're looking for? Use a shapefile to define the region?
Yes.
We'll do that. That should be easy. We've been asked that question before. So again, you will be referring to, so in here, it's going to look for a shapefile by a given name that's going to be in this folder right here called shapefiles. And so this is all on your server. So that's how it's done. It grabs that shapefile, defines that region. You can always do it, if you knew the lat-lon bounding box, you could do it that way too. But shapefiles are nice. I agree. We'll certainly do that.
Oh, thank you.
Another thing I want to point out, just so that you're clear, if several of you are trying to play with this separately, notice all of these, I've only got single copies. If you're interested in this NDVI anomaly, which I've just worked on, I would suggest what you do is you click on the left side to the name of the file and you hit duplicate. What that does is it creates a copy of that file. You can also do it when you're here. You can do file, make a copy. And if you make a copy, what it'll do, so let me just duplicate that now. I hit duplicate. And notice it just increments it to NDVI anomaly copy. I come up here and I click rename, and I might call this NDVI anomaly Mugambi. And now you can be the only one that's running your own version of this. Where did I put that thing? It disappeared. Oh, here it is, NDVI anomaly Mugambi down here. I renamed it, but you could be the only one running this. And oh, I don't know why it just did that. All right, I did that one wrong. My apologies. Let me delete that one for a moment. Do it from this way. Once you're in here, just make a copy of the end. Open it up, make a copy there, rename the copy at the top like NDVI anomaly Mugambi, hit rename, it's done. I'm gonna shut these down. If I come over to the home tab, it should now be there, NDVI anomaly Mugambi, NDVI anomaly. So now both of these are there. So you can make a copy, open it up first, make a copy, and that way multiple people can be running multiple versions, because right now this one's your main version. And another thing to do, notice over here on the other tab, things that are running. If they're running, they're using memory and they're running in the background. So just so that if I want to speed things up and I haven't used it in a while, I can turn all these off and I can just shut them down. And basically it takes them out of memory and now nothing is running. So if I choose one of these to run, it will run significantly faster, because I can look at any time on what's running. And right now, the only one running is this NDVI anomaly. So I use the running tab to keep a pulse on what is executing, because it's important that you know what's happening. Okay, any other questions?
And one more question.
Mm-hmm.
Yeah, is it possible to, this one can be simply customized so that it can be easily to users? As instead of using codes, yeah, there is somehow it's customized so that it's somehow simplified to users.
Not sure I understand the question. You were talking about custom? Customizing which portion?
This analysis software.
You mean like one of these notebooks, like customizing a notebook?
Yeah, notebook.
Yeah. So you can certainly do that and change this completely. So remember, you have some of these baseline copies, like the training notebooks and the ones that I just demonstrated for you today. Again, if you want, I suggest just opening any one of them and hit make a copy. And if you do that, now, like for instance, the one I just made with Mugambi's name attached to it, you can customize that and do anything you want to it, and it's your own copy.
Okay.
It's just, if everyone goes in and starts playing with NDVI anomaly, then your baseline copy will not, is going to change. So I always suggest make a copy for yourself, run your analysis case with maybe your name attached to it, and that way you have control over those and that the original ones stay intact. Any other questions?
Yeah, one more. Yeah, I can see this system is hosted in a certain server, and that means once someone does analysis, it can be accessed by someone else, isn't it?
Yes. In other words, can someone else access and see it and look at the analysis?
Yes. So is it possible someone once does analysis can share with a limited number of people?
Yes, certainly. Well, the system is yours. So in the document, at the top, let me just go back to this document. At the top of the area for the notebooks, here it is right here. This website is your Tanzania notebook website, and this is your password. You can, and we could do this for you, we could change that password to whatever you want it to be. We can just leave it as is. You can decide to share this website and password with anybody, but just be careful because then anybody can be working on this system and be modifying files and so forth. So if someone's running an analysis, you can share the results with them by telling them to go to this site, open up NDVI anomaly. They can start to look at, the products. What I like to do is run the analysis, and then if I want this product, I just right click and put save image as, and then I save that image out to my screen and I share it that way. Any one of these images that you get, you just right click save image as, and I can save it as a PNG. So you can share these results. If someone understands how to run the code, they can go in and actually visit the site. But if you want to share the results in another way, I would export and pull the products out and put them in a document. That would be my suggestion. But anybody you give access can have access to this right here. They can create their own notebooks. They can modify these notebooks. Remember, these are the training notebooks down here, so you might want to go back through the training notebooks if you have some questions about water. Like we didn't even talk about water today and other indices. There's a number of other indices and water things in there. And you can take bits and pieces of these other notebooks and create your own. And I do that all the time. So my guys are always creating new notebooks, and I pull these things together in bits and pieces.
Okay. Another thing, Mr. Brian, I understand you about this is the site for Tanzania.
Yes.
The site link in the password, meaning that anyone can access it at his own time. So, if we are, let's say we are 10 people, we have to share the same password, meaning everyone has to get the same password to access the site. Or is there a way we can have the site contains some members so that everyone can have his or her password to access the site at its own time?
So do you want, are you suggesting, so I guess what you're talking about is trying to have a bit more control over the site, correct? And who accesses?
Yes.
Yeah, we can certainly help you do that. You know, one of the things that Strathmore University, you know, wants to do. I mean, their job in the African Regional Data Cube is to help manage the very country instances. So Tanzania has a dedicated user interface and a dedicated notebook area. And if you want to change those passwords because people are getting in that you don't want to get in, you have complete control over changing those passwords and adding more passwords if you want, doing however you want to manage it. We can help you get to that. There's a lot of flexibility, so it's up to you how you want to share this with people. I would suggest somebody in your area that has a bit of knowledge of these systems to keep an eye on it and to make sure that it's not being used in wrong ways, or very large jobs are running and crashing the system. Because if someone sets up a job in a notebook running all of Tanzania, it could really pull all the memory in and not run correctly and crash. So you have to be careful.
Sure.
We can help you with that. If you have some particular things you'd like to do, send them to me in an email, and I will try to contact Strathmore, because this is something Strathmore needs to be doing in the future as we go forward. It's their job to manage all of this for you and to make things run seamlessly as you have issues or as you have needs. Okay?
Sure. I think this observation, of course, it has to be taken into consideration as what you said now, that perhaps we are going to write an email formally, but in fact that is the way Normal would wish to go for.
Okay.
We are changing the password as well as the
Yeah, we could change the password easily. So if you wanted to change the password, tomorrow from ARDC user to something else, we would be more than happy to do that for you rather quickly. And then that would give you complete control of who you give access to, because then you would only know the password.
That's very fine.
Yeah, that's easy. Just let us know. We can do that pretty quickly.
Okay.
So I hope you found this useful today. I hope the documentation is helpful to you, and this interaction was helpful.
Yeah, of course. Thank you. And then we'll be having a discussion here, and of course we'll be sending you an email, a summary of what we've done today, and again, what are we proposing, so that you can help us.
Fantastic. Yeah, we'd be more than happy to help, and I'm glad to see that you have an interest in this. I think these tools can be very valuable to answer a number of critical questions for you. And the key to all of this is, again, you have the control of the data, you have the control of the products and the analysis, and it's important that we help build your capacity to do this yourselves, because you'll take much more interest in it and feel confident about the results if you have the control. Okay?
Thank you, Brian, for now.
Okay, thank you. If that's all, I'll wrap up here today, and thanks again for your time and have a great evening.
Thank you.
Thank you.
Thank you.
Thank you.
Okay, bye now.
Bye.
I say, someone did give us kidogo gani ili tumtumie. Hizo information za zote nzuri. Hata hiyo nzuri zaidi kwa sababu itengeneze mtandao